Take a plastic bottle, any bottle near you right now. Water, soda, juice, doesn't matter. Hold it in your hand and really look at it. Notice those spiral lines wrapping around the bottle. They twist, they repeat, they look intentional. But here's the strange part. Most people think they're there for grip. Some think they're decorative, others think they're just part of the mold. But the truth is much more surprising. If those spiral grooves didn't exist, this bottle might collapse, deform, or fail before it ever reached the store. No joke. That tiny design detail is silently solving multiple engineering problems at once, problems you never even realized existed. And once you see it, you'll never look at a plastic bottle the same way again. Here's a fast fact. Most people don't know, a smooth plastic bottle without ribs or spirals can lose more than half of its structural strength when exposed to pressure changes, heat, or cooling. Those spiral grooves do more work than the plastic thickness itself. They are the difference between a bottle that survives and a bottle that fails. When plastic bottles first started replacing glass, the goal was simple: make packaging lighter, cheaper, safer to transport. Plastic seemed perfect. It didn't shatter. It was easy to mold. It reduced shipping weight. So early plastic bottles were designed to look clean and modern, smooth, straight, simple cylinders. And at first, everything looked fine, until reality hit. During transport, bottles collapsed. In hot trucks, they bulged outward. After cooling, they sucked inward. On shelves, they warped. In warehouses, stacked bottles crushed each other. Entire shipments were destroyed. Not because plastic was bad, but because plastic behaves very differently from glass. Glass is rigid. Plastic is flexible. And flexibility without control becomes failure. Manufacturers were losing millions, so engineers were brought in to solve one question: how do we make thin plastic behave like a strong structure without making it thicker? Plastic bottles face three invisible enemies every single day. Enemy first, internal pressure. Carbonated drinks constantly push outward. Heat causes the air inside the bottle to expand. In a smooth bottle, pressure doesn't spread evenly. It finds weak spots. Those spots bulge, and bulges turn into cracks. Enemy second, vacuum collapse. Now reverse the situation. A hot liquid cools after sealing, air contracts, pressure drops. The bottle tries to collapse inward. That crinkling sound you hear when you squeeze a bottle, that's the structure giving up control. Enemy third, vertical weight. Think about warehouses. Thousands of bottles stacked on top of each other, layer after layer. A smooth plastic wall has nothing to resist vertical compression. One weak point, and the entire stack collapses. So engineers needed a bottle that could expand safely, compress safely, recover its shape, distribute force evenly, all while using less material, not more. This is where the spiral shape enters the story. Here's the key idea. Spiral grooves act like structural reinforcement ribs, just like corrugated cardboard, reinforced concrete, truss bridges. Shape adds strength. But why spirals? Why not straight vertical lines? Because straight ribs only resist force in one direction. Pressure doesn't come from one direction. It comes from everywhere. Spiral ribs wrap around the bottle, allowing stress to travel along the curve, spread across the surface, avoid concentrating at a single point. This turns the bottle into something very special. Not rigid, not weak, but elastically strong. When pressure increases, the bottle expands slightly. The ribs guide the expansion. The shape holds. When pressure drops, the ribs resist collapse. The bottle keeps its form. When you squeeze it, the grooves compress. Energy is absorbed. The bottle springs back. This is controlled flexibility. And here's the genius part most people miss. A spiral bottle can be stronger than a smooth bottle using less plastic. Not thicker walls, not heavier material, just smarter geometry. Multiply that by billions of bottles, and suddenly, shape becomes one of the biggest material-saving inventions in modern packaging. Now let's talk about something invisible, your brain. Humans subconsciously associate texture with strength, structure with safety, grooves with durability. A smooth bottle feels cheap. A ribbed bottle feels engineered, even if they're made from the same plastic. That's why you squeeze textured bottles harder, trust them not to burst, carry them more confidently. Designers know this. So the spiral shape does two jobs at once. It strengthens the bottle physically and strengthens your trust psychologically. Great design always works on both levels. Today, bottle design is highly optimized. Engineers use computer simulations to test pressure cycles, drop impacts, heat exposure, cooling contraction, long-term fatigue. Every groove angle matters. Every rib depth is calculated. That's why different drinks have different spiral patterns. Water bottles, flexible, easy to squeeze, lightweight. Soda bottles, thicker ribs, pressure-resistant, reinforced bases. Juice bottles, designed for stacking, shelf stability, shape retention, same principle. Different execution. No spiral is accidental. So the next time you open a plastic bottle, remember this. Those spirals aren't decoration. They aren't grip lines. They aren't random. They're silent engineers. They fight pressure. They prevent collapse. They save material. They reduce waste. They protect your drink. And they do it so perfectly, you never even noticed. That's the power of truly great design.